Today we are working on 7.2. Deals with parallelograms. What is the definition of a parallelogram? A quadrilateral with two sets of parallel lines. Now, that is the definition, but several things that occur once you define parallelogram is, just like a rectangle, you have two sets of equal sides. Okay? Also, you have two sets of equal angles. Those are not part of the definition, but they're easily provable once you have the definition. And we're not going to bother proving that today. So knowing that, we have some information here. Find the value of x and then find angle xwy. So xwy would be this angle. And then the measure of angle x, which is this one. Well, what value of x will satisfy that parallelogram? 5. So 4x and 20 have to be equal. 4x equals 20 divided by 4, and you get 5. So little x is 5. Okay. What about angle x? Well, in a parallelogram, you have two sets of two sets of congruent angles, so it has to be 102. Okay, so angle x is 102. Okay, what about this angle here? It's not going to be 43. Well, here I have two parallel lines cut by a transversal. How would you describe this angle and that angle? They're supplementary because they are consecutive interior. So 102 and this angle have to add up to 180. So this angle here must be, well, the big angle, the whole thing is 78. Everybody understand why? So this degree measure here is 78. And I want to know this one. So 78 minus 43 is 35. Okay, let's do another one. This is 7.2. All right, same idea. What is the value of little x? It's got to be 5 again in this case, because 5x has to equal 25, so it's 5. Okay. What is the measure of angle R? 84. Okay. What is this angle measure? 96. So we have two parallel lines cut by a transversal. So this angle and that angle are classified as consecutive interior. Consecutive interior angles are supplementary. So 180 minus 84 is 96. That describes this whole angle. And if I subtract 53 from that, I get 43. So this measure is 43. All right, let's go to the next problem. Okay. This is a little strange. We have a parallelogram, and we know some things about this parallelogram. We know that this distance here is how far? Well, how high is this point? S. So this point here is 0s. So this length is s. Okay? How long is that length? Well, yeah. The length is t. The point is at negative t. Okay? How big is this point? That length? That length is u because the x coordinate is u. So where is g? How tall is g? Point G. So the height of G is going to be the same as the height of F. So the height is S. Okay? And then how far to the right is G? U plus T. So it's all of U plus all of T. So point G is U plus T, comma S. Okay, let's do another one. All right. Here we have a rhombus. So a rhombus has 4 equal sides. We know that this length is U. We know that this length is V. So what would the coordinate of G be? How far to the right is G? So G would be positive U. How far up is G? 0. And F? 0, not V, negative V. Okay, let's do another version. Okay, we have an isosceles triangle, which means those two lengths are equal, which means that these two lengths are equal. Okay, so point N, how far to the right is point N? T. How far up is N? 0, so it would be T comma 0. Okay, you guys get the hang of those? Do you need to see any more? No? All right, let's move on. Okay, here we have 3 of the vertices of a parallelogram. We want to give the coordinate of the 4th vertex. So it's going to be somewhere, oops, it's going to be somewhere about there. How are we going to find that? Any recommendations? Yeah, similar to what we just did, right? So I'm going to draw this line to kind of help us. Okay. Where would the center of that be? How would we find the center of that, of the diagonal? Well, where is the center in reference to these 2 points? Well, it has to be halfway between the x's and halfway between the y's. How do we find the average of 2 numbers? Add them together and divide by 2. So let's look at the x's. -7 and +5. If I add -7 and +5 together, what do I get? -2. And then to take the average, I divide by 2. And so the midpoint is going to be -1 for the x's. So -1 is halfway in between the leftmost point and the rightmost point. Okay. What about the y value? What is halfway between 4 and -5? So 4 plus -5 is -1. Cut that in half, and I get -1/2. Okay. So if I graph that point, -1, -1/2, right here. What does that tell me? How does that help? Well, how do I get to this point from here? How far to the right do I have to go? 4. Okay. And then how far down do I have to go? 1/2. So how would I find the other point? Not up 4. So we do the exact opposite. So I'm going to go left 4 and up 1/2. So if this point is -1, -1/2, what happens when I go left 4? What do you get? What's left 4 from -1? So if I go left 4 from here, I get -5. Okay, and then I need to go up 1/2. What happens when I go up 1/2 from there? 0. Okay, now there are more ways to do it. So that's the way that one way to do it. Tyson, how did you do it? Okay, that works. Okay, so Tyson said, all right. Which points did you use? Okay. So Tyson said this slope right here is up 5 and right 2. So if I went up 5 and right 2, where would I land? So up, did I go up 5? Is that right? Yeah, up 5 and right 2. So up 5 would turn that into a 0, and right 2 would turn that into a -5. Okay, did anybody else do it a different way? Okay, we'll use Tyson's way. I like that better. Okay, so what is the slope from here to here? The rise is -2, went down 2, and the run is +5. I went right 5. So here, we need to go down 2 and right 5. Down 2 would give me a 6, and right 5 would give me a +3. Good job, Tyson. I like your way better. Does that make sense? Do you want to see another one? Yeah? Okay. Let's go from here to here. How far did that drop? We went from -7 on the y to -10 on the y. So we need to drop 3. So we're going to drop 3. If we're at -2 and we drop 3, we're at -5 now. And then how far did we run? 8. So if I run 8 from -3, -3 plus 8 is 5. So this point here is 5, -5. And if I connect all the points, I should get a parallelogram. It doesn't really matter. So she's asking, how did I know to choose this one? It doesn't matter. So you can either, so if it helps to draw the shape to begin with, so if I want to take this point to here, then I need to go down and over, so I measure this. But you could very well say, from this point, I want to go left and up. So there are a bunch of different ways to do it, and they all sort of work. So just choose one that makes the most sense to you. All right, that's 7.2. Get to work.